Here's some homework help for lesson 5.1. This is from pages 318 and 319. Picked 3 problems to work out for you. Number 11 is from the block of problems where you're given 2 functions and you're performing all 4 operations on these functions. And so what we mean by operations, we mean addition, subtraction, multiplication, and division. So let's just get right to it. We're going to, in letter A, answer part A, we're going to add these 2 functions together. So the f function is 3x squared minus 4. And I'm going to add to that the g function, which is x squared minus 8x plus 4. And then you just combine like terms, and 3 plus 1x squared is 4x squared. And there are no other linear terms besides this one, so minus 8x. And negative 4 plus 4 makes 0. So f plus g of x will be 4x squared minus 8x. Letter B means to subtract them, so be careful with subtraction. The f function is 3x squared minus 4. And I'm going to be subtracting the g function, so notice I'm going to put it in parentheses as a reminder that I am subtracting each one of these terms individually. So without parentheses, it would look like this: minus x squared plus 8x minus 4. Remember, distributing negative 1 to all 3 of those terms. And now we're back to what we were doing before, combine like terms. 3 minus 1x squared is 2x squared. There's only one linear term, plus 8x, and negative 4 minus 4 makes negative 8. So f minus g of x is 2x squared plus 8x minus 8. Okay, now we have to multiply the f and the g function, so let's set that up. 3x squared minus 4 times x squared minus 8x plus 4. And so we're going to multiply this binomial times a trinomial, which means think of the distributive property, but you're going to be doing it twice. You're going to distribute each one of these terms. I'm going to show the horizontal method. If you prefer the vertical method, that's certainly okay. But here's the result of distributing 3x squared to each one of these. So that would be 3x to the 4th. And then 3x squared times negative 8x is negative 24x cubed. And then 3x squared times 4 is positive 12x squared. And now I'm going to distribute the negative 4. Negative 4x squared. That would make plus 32x. And then negative or minus 16. Okay? And now once again we combine like terms. There's only one quartic term, 3x to the 4th. We'll just mark that out. And there's only one cubic term, minus 24x cubed. When we put these quadratic terms together, 12 minus 4 is positive 8x squared. Okay, we can mark those out. Plus 32x minus 16. So there is the result of multiplying the 2 functions. And then the 4th part of this answer will be the division of these 2 functions. So we have the f function divided by the g function. And since we can't factor either one of these parts, the numerator nor the denominator, there's really nothing else we can do to simplify this fraction. Just be on the lookout for opportunities to factor, because then you might have opportunities to reduce. We can't do anything else to this to reduce it, but we do need to make sure we take care of indicating restrictions on the domain. So we've taken care of the simplified fraction. Actually, there's nothing we can do to simplify this. But in finding the domain restriction, what we're looking for is a number that could plug in for x, an input that would cause this denominator to become 0. we talked in class today how that we have to always be on the lookout for preventing division by 0. Now, in this denominator, there are actually two numbers that would create 0 when they are plugged in for x. And they're probably not going to be obvious to you just by looking. So whenever this happens, when it's not an obvious situation, you can always take this denominator and make it equal 0 and solve for x. So basically what we're doing is we're going to solve this quadratic equation. Unfortunately, it doesn't factor. That would make it pretty easy to solve. So we're going to have to use the quadratic formula or completing the square. So using the quadratic formula, we would do the opposite of b, plus minus the square root of b squared minus 4 times 1 times 4 all over 2, and then we'll simplify this radical. The square root of 48 would simplify as 4 times the square root of 3 all over 2. And then we can reduce, dividing 2 into these numbers, we would get 4 plus minus 2 times the square root of 3. So our domain restriction, we'll state it this way. We cannot let x be negative 4, or positive 4 actually. 4 plus 2 times the square root of 3 and 4 minus 2 times the square root of 3 are both, they have to be outside of the domain, or in other words, we're going to restrict our domain. We cannot let x be these two numbers, because if we did, we would create a division by 0. So it's just really a two-part answer. Here's the answer to the division, and then this would be the domain restriction. Okay, moving right along to number 13, this word problem. We have these two functions that model the population of two different cities. And letter A is basically wanting to know, what would this look like if we combine these two functions? What is the population of the two cities after any number of years? And that's really just doing what we were doing earlier with adding two functions. So we're going to take the f function and we're going to add to it the g function. And when we do, we'll come up with our answer. Our f plus g of x will be 200 plus 175, that's 375x, and then 25 minus 15 is 10. So the answer for part A is really the sum of those two functions. Part B, pretty obvious. What is the difference in the populations of the two cities? So now we're going to be doing subtraction. F minus g of x. And so that's 200x plus 25, and now we're going to subtract the g function. 175x minus 15. So again, be careful with subtraction. 200x minus 175x is 25x, and 25 minus negative 15 is really adding. That's going to be plus 40. So f minus g of x, 25x plus 40, that's our answer for the difference in the population of these two cities. Okay, got one more for you. This is number 16. Given these two functions, the f and the g, what do we have if we divide those? So let's take the f function as the numerator, x squared plus x minus 12, and the g function will be in the denominator. We mentioned this in class, so just a reminder, always be looking out for opportunities to factor and cancel. We can factor this numerator. There are factors of negative 12 that add up to positive 1. 4 times negative 3. can't factor the denominator, but we do see an opportunity to reduce this because we can cancel these two factors, leaving us with the answer to the division. The f function divided by the g function will just be x plus 4. And then the follow-up answer is to state the domain of the resulting function. A lot along the same lines as stating the domain restriction, except now we're basically saying, well, what is the domain? We can say the domain is all x such that, now be careful here, because even though we canceled this factor x minus 3 to reduce to come up with our final answer, when I come up with domain, or whether you want to call it the domain, which is a list of all possibilities, or the domain restriction, which is the numbers that we're going to leave out, we need to look at the function before we canceled. Okay, so some people would think, well, I canceled x minus 3, so I don't have to consider that any longer, but that's not the case. When I'm stating my domain restriction, I'm looking here before I canceled, because I still have a number that I need to leave out of the domain. I cannot let x be 3. So just keep that in mind. Even though you canceled and it looks like you no longer have a denominator, look at the pre-canceled version of your function to get domain restrictions. That's extremely important. Alright, so it's a two-part answer here. The f divided by g of x is here. That's x plus 4. And then we'll call our domain all x such that x cannot be 3. So that is it. I hope this helps you with the other problems on the assignment. If you have any questions, let me know.